Okay, Wildcats. Just a reminder again, I'm presenting a workshop at NASA's uh, teacher conference, global teacher conference. Actually, there's going to be teachers there from all over the world um, on Thursday and Friday, so I'll be absent. So because of that, I'm going to go over all the examples, and I'm going to actually demonstrate the assignment as well, so you can check that. And those I'm going to check on Monday. I'm also asking that you have the test 7 review done for class on Monday, so that way we can go over it together, because I'm going to be out on Tuesday because part of a 9 or 10 teacher team with the principal that's going to Georgetown to observe what they're doing with flipped classroom and blended learning and all of that. So just kind of update on what's going on in the near future. So with that, finish updating your table of contents, and let's move on to the examples. There are no notes, so let's move on to examples. All right, so let's look at example 1. It says solve algebraically and check. It also says solve graphically. We're going to check graphically. Okay, so to solve this algebraically, what we need to do is move everything to the one side, preferably with the x squared, so that we can factor and solve. So we're going to subtract 2x and subtract 1 from both sides. Those become 0. You're left with 2x squared minus 2x, and then 1 minus 1 is 0, equals 0. Okay, so it looks like there's a greatest common factor of 2x, so we're going to factor that out. So that's 2x times x minus 1 equals 0. Okay, so we said each equal to 0, so we have 2x equal to 0 and x minus 1 equal to 0. Well, you divide 2 by both sides, so 2 divided by 2 is 1, 0 divided by 2 is 0, so x equals 0. Add 1 to both sides, x equals 1. All right, so now we need to check. Okay, so let's check 0 first. So 2 times 0 squared plus 1 equals 2 times 0 plus 1. 0, that's left with 1, that's 0, 1. So 1 equals 1, so that checks. Okay, now let's check the 1. So then that's 2 times 1 squared plus 1 equals 2 times 1 plus 1. 1 squared is 1, 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, plus 1 is 3. So both answers checks. Now, to check graphically, I'm going to graph the left side in orange and the right side in blue. We can actually start with the right side because it's easy to graph. We start at a y-intercept of 1. And then the slope, technically that's 2 divided by 1. And I guess you could rewrite it as this: 2 divided by 1x plus 1. And the reason why we'd write that, because that's our slope. Okay, so from here we go up 2 to the right 1, 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 down 2 to the left 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 1. All right, so now we're going to graph by direction. So we know if it's quadratic, then we know it's -2, 4, -1, 1, HK, 1, 1, 2, 4. So we can go and move the vertex, which is up 1, which already verifies that they intersect at x equals 0. Now, here, it's a vertical stretch of 2, so we have to multiply all the y's by 2. So that's 8, 2, 2, and 8. So from a new vertex, we go to the left 2, up 1, 2, 3, 4, 5, 6, 7, 8. And left 1, up 2, right 1, up 2, right 2, up 8. Which checks because they intersect at x equals 0, and they also intersect at x equals 1, which is our solution. All right, let's look at example 2. All right, so we have 3 terms on the left, and it looks like we could factor. So we want to draw a box. So first term, last term. Now we know that 2x times 1x makes 2x squared. Now we need to find all the combinations makes 3. Since the last number is positive, the middle number is negative, we have to multiply by negative numbers. So -1 times -3 and -3 times -1. Okay? So we just have to try each number to see if we can get it to work. So let's try -1, -3. So 2 times -1 is -2x. -3 times is -3x. We want them to equal -5x, which they do, so this is factored. So we have 1x minus 1 times 2x minus 3 equal to 0. Set them both equal to 0, so 1x minus 1 equal to 0, 2x minus 3 equal to 0. Add 1 to both sides, x equals 1. And add 3 divided by 2, x equals 3 divided by 2. Which we can also write as 1.5. All right, so we want to check. So let's start with 1. So 2 times 1 squared minus 5 times 1 plus 3 equals 0. Well, that's 2 minus 5 plus 3 equals 0. Well, that's 5 minus 5, so 0 equals 0. So it checks. So then let's check. So that's 2 times 1, or 1.5. Actually, we can probably do 3 over 2 squared minus 5 times 3 divided by 2 plus 3 equals 0. Well, that becomes 9 over 4. See, 3 squared is 9, 4. 9 times 2 is 18, so that's 18 divided by 4 minus 15 divided by 2 plus 3. And you can plug that in the calculator and you see that that equals 0 equals 0, and that checks. All right. So now, let's graph the left side and the right side. So 0 is easy. We just draw a horizontal line at 0. Now to graph this, we can graph using the vertex and the y-intercept. Okay? So vertex, we know that h equals negative b divided by 2a. So that's negative 5 divided by 2 times 2, which is 5/4, which we can write as 1.25. Now we plug that into the original equation, so that's k, and I'm going to steal some space here, k equals 2 times 1.25 squared minus 5 times 1.25 plus 3. And if you plug that into your calculator, k will equal negative 0.125. And then our y-intercept is at 3. So our y-intercept is 0, 3. So 0, 1, 2, 3. Our vertex is at 1.25, negative, so about there. And so then we know that if it's 1.25 from here, it's going to be about 1.25 from here. And we can see that it crosses, and my sketch might be a little off, but at 1 and 1.5. Now, when a problem like that has kind of decimals that are you kind of have to approximate, what I recommend doing is actually using your calculator to verify that. Okay? So we're going to go to New Documents, No. Sorry, there was a glare on the calculator. I had to go turn the light off. All right, so now we go to Add Graph. And so we're going to graph 2x squared minus 5x plus 3, tab 0, and then we're going to go to Menu, Analyze Graph, Intersection, click, drag. You can already see that it says 1. Okay. So that verifies our first conclusion. Now I'm going to do it again. Menu, Analyze Graph, Intersection, and I'm going to come from the other direction. Click, drag. Click on one of the points, and you can see that it verifies that our solutions are correct. Okay. All right, now let's move on to example 3. Our example 3. We have square roots on both sides, so our first step is we can square both sides. Now, I'm going to rewrite this as negative x plus 1, which we can do that because we know that 1x is equivalent to negative x plus 1. Okay, this becomes the power of 1. Power of 1, you're left with 1x minus 1 equals negative 1x plus 1. Now, whenever you have x's on both sides, you want to take the smaller one and move to the other. So since that's smaller, I'm going to add 1x to both sides. So we get 2x minus 1 equals 1. And then you can add 1 to both sides, divide by 2. When you add 1, you get 2. And actually, I think we're just going to have to do it all in one step. So you add 1 to both sides, you get 2. 2 divided by 2, so x equals 1. All right, now let's check. Okay, so then we do the square root of 1 minus 1 equals square root of 1 minus 1. That's a square root of 0 equals square root of 0, so that checks. All right, so now let's graph. Graph the left side in orange and the right side in blue. All right, so again, we're going to graph by direction. All right, so my recommendation in starting is 1, because the square root of 1 minus 1. Actually, whoa, no, what am I doing? Graph by direction, I'm sorry. All right. Let's see. So that minus 1 moves it to the right one. So our new vertex is 1, 0. And then from there, we know our direction is HK 1, 1, 4, 2, 9, 3. So we go to the right one, up 1. We go to the right 1, 2, 3, 4. 1, 2, 3, 4, up 2, 5, 6, 7, 8, 9, up 1, 2, 3. All right, and now we graph next by direction. All right, so first things first, we move the vertex. Let's see, and that is a +1, so we go to the left one, but here's where you have to be very careful. That reflects over the y-axis. So while we go to the right one, if we reflect over the y-axis, we're back at 1. And that's what you have to be careful with on the directions. So we know our directions are HK 1, 1, 4, 2, 9, 3. But in this case, because the negative's on the inside, square, we have to multiply the x's by -1. So that's actually -1, -4, -9. So then we get, and so you have to be careful when the negative's on the inside of the square root. So then we go left 1, up 1, left 1, 2, 3, 4, up 2, left 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And we can see here that they intersect at x equals 1. And again, whenever there's questionable graphs, I like to check on the calculator. So let's verify that in fact we did that correct. So new document, no, add graph. So we graph the left side. So control square root x minus 1 tab, control square root of 1 minus x, and you can see that it verifies that we did it correctly. All right, now let's look at the last example. All right, example 4. All right, so first thing we need is isolate the cube root. So we're going to subtract 6 from both sides. That becomes 0. You get the cube root of x minus 1 equals 1. Then you cube both sides. Becomes a power of 1. You get x minus 1 equals 1. Add 1 to both sides. X equals 2. And I don't know why I didn't put lines here, but I can do that quickly. All right, so let's check. So we substitute 2 in, so that's the cube root of 2 minus 1 plus 6 equals 7. Well, 2 minus 1 is 1. The cube root of 1 is 1. 1 plus 6, which 7 equals 7, so it checks. All right, so now let's graph the left side and right side. All right, so 1, 2, 3, 4, 5, 6, 7. We just graph y equals 7. Okay, and now we move the vertex. So minus 1 means we go to the right one and then up 1, 2, 3, 4, 5, 6. And then we graph by direction. So we know HK 114293. So from here we go 1, 1, and then to the right 1, 2, 3, 4 up 2, 5, 6, 7, 8, 9, 1, 2, 3. You can see here that they intersect at, looks like x equals 2, which verifies that in fact x equals 2 is correct. All right. So because I'm going to be absent, give me a second, I have to get it. Let me let you go ahead and check your work. So what I would do at this point is pause the video, work the assignment, and then come back to it as you're working so you can check your work, okay? Now you'll notice I didn't graph number 2. We can probably talk about that when I get back. I couldn't see a legitimate way to graph number 2 where that made sense. But now that I think about it, you could probably graph by the vertex. And I don't know why I just clicked in my head now, so we can do that. So left side, right side. But because you have the negative 1/2, it's probably going to be good to check it on your calculator as well. But we know that h equals negative b, which is negative 7, divided by 2 times a, which is 2 times 2, which is negative 7/4. So h equals negative 1.75. And then to find k, we substitute that value in to the equation. So probably going to steal some space here. K equals, see, so 2 times negative 1.75 squared plus 7 times negative 1.75 plus 3. So k equals negative 3.125. No, y-intercept is 0, 3, so 1, 2, 3. So negative 1.75, negative 3.123 is about right there. We know we're graphing 0. So this is about negative 1.75 here. So we go about right there. Which looks like about negative 1/2 looks good. And 1, 2, 3. We're very close to the negative 3, which makes sense. But again, I would probably graph this on your calculator to check. So new document, no, add graph. So 2x squared plus 7x plus 3. Tab 0. And this is why checking with the calculator is a good idea. And good thing I always come prepared with whiteout is I made the mistake it's kind of silly, but I wrote negative, but I went to the positive. So real easy, we just use this magical whiteouts. So beautiful. And then we can correct that. So we actually need to go negative 1.75s here. Down 1, 2, 3, about right there. And our y-intercept is still at 0, 1, 2, 3. And I'm glad I made that mistake because that's what I'm showing is exactly what I would do on a test is I do it by hand and then I use my calculator to check. Okay. But now let's check the intersections. So then menu, analyze graph, intersection, click, drag. Control click. That verifies menu, analyze graph, intersection, click. And so why that didn't work is I have to go to the other side. Menu, analyze graph, intersection, click, drag, and control click verify. So that verifies that in fact we're correct. Now understand also because I've shown you this, when we do a test, if you just put the points and no work, like if you do show the points but you don't show this part, and this is what happened in the last test, is you lost like almost 5 to 10 points by not showing this. So make sure this is great, but make sure you show it without the calculator. Okay. All right. Now, if you would go and check 3 and 4. All right. Now you can check problems 5 and 6. Okay. And then go up a little bit. And then you can check 7 and 8. All right. So I guess I will see you back on Monday, January 5th. Make sure that you have the test 7 review completed before class because we're going to go straight into I'm going to check your 2 assignments Thursdays and Fridays, and then I'm going to check to see that you have test 7 review completed so that we can go start answering questions, go over that together. Also make sure that you have your journal completed as well. So with that, have a wonderful Wildcat